So in this video, we are introducing the concept of a cut, which is a really quick and efficient way to figure out the maximum flow throughout an entire network. And it's going to be really useful as we get to some of these tougher directed graphs and networks with a lot of edges and vertices, where it may be hard to figure out this maximum flow in the long way that we did in the last video. Now, a couple of key points here is that a cut is basically an imaginary line that we draw across our directed graph, which will separate the source from the sink. And when we talk about the capacity of the cut, it's the sum of all capacities of the edges that the cut passes through. So you remember with networks, we have weighted edges. This can tell us, for example, the flow rate through a system of pipes or how many cars can pass through a set of roads. And when we do this, we need to take into account the direction of flow. Now, if you look at these two examples below, I have two pictures. Now, the first point tells us that the cut has to separate the source from the sink. Now, you can see on this left-hand side, our cut basically goes all the way along through here. So imagine these are pipes and there's water flowing through these pipes. At every point, we have cut off the source from the sink. So there's no way that water can pass through from one end to the other. So this thing we're going to call a cut, because it basically cuts off every network system from the source to the sink. So if these were pipes, we make a cut, water would flow everywhere. There's no way we can get flow from the source to the sink. Now, the one on the right hand side, you can see that we have cut through the network a little bit, but we can still see a path where water, for example, would be able to flow from source to sink. Therefore, based on this first point that we defined, we haven't completely separated the source from the sink. So this is not a cut. So we have to explicitly define these two concepts. Now, where we can see it being useful is the example we looked at in the previous video. Now, we said that the maximum flow through here was 450 at any one time. We looked at this first path at the top, and we said that the maximum flow through here is 300, and the maximum flow through here is 150. Now, where a cut is useful is that we can, by separating source from sink, we can draw in a line that passes through. We can start at the top. It can pass through our edge that has the smallest possible weight up here, and it can pass through the edge that has the smallest possible weight here. Now we have 300, that's our maximum flow up here, and 150, which is our maximum flow down here. So we can really quickly, and you can imagine as this gets really complex, as we've seen with other network diagrams, this can be a really useful method for finding the maximum flow a lot quicker. So in the last part of our video now, we are just looking at determining the cut capacity for some different cuts on a network diagram. Now, one particular thing I want to draw your attention to is this second point that we had up the top here, which was that we have to take into account the direction of flow. So the only weighted edges that we basically count once we've made our cuts is the ones that are going from the direction of source to sink. So in this particular question, it tells us that the source is vertex S, so this guy over here, and the sink is vertex T. So this guy over here. Now what we're going to do, we're going to check all these cuts to make sure they separate source from sink. So they cut through, leaving no flow from source to sink. And we're basically going to sum the weighted edges that go in that specific direction. So for cut one, we can see it's this one over here. Now it separates, well, it cuts through, I should say, these two weighted edges. One is 15, one is 20. And we can see it separates source to sink, so now we can figure out the cut capacity. So all we have to do here, it's simple addition. We're just going to add 15 and 20, which is going to give me 35. So this cut has a capacity of 35. Now moving on, we have our next cut. Now we can see here we have to take into account the direction. Now this guy goes in this direction, this one goes in this direction. But you can see this one here, it's a vertical line basically. So here it's too vague to be able to see whether it flows from source to sink. So this one we are going to ignore. When we look at our direction of flow, we are looking for ones that are clearly going from source to sink. So they can look kind of diagonal like this. These ones we do count, but the ones on the left here, the ones in the opposite directions, or if they're vertical or horizontal, if they're vertical in one direction or the other, we are not going to count those. We specifically want the ones that are going from source to sink, so left to right in this case. So for cut 2, we are only adding 20 and 14. So we're adding 14 and 20, so that gives us 34. Next one, we're looking at cut 3. So we can see that this cut passes through this edge, and this edge. And they separate source to sink, and all of them are flowing in a direction from left to right. So we are going to add those. So we have 14 plus 15 plus 20. That is going to give us 49. And finally, we're looking at cut 4. Now we're considering which edges it passes through. We have this edge here, this edge here. Those are in a direction from source to sink, but this third one goes in the opposite direction. So we are not going to consider that when we count the cut capacity. So for here, the only two numbers we're adding is 20 and 10. So the capacity of cut 4 is 20 plus 10, which gives us 30. So this is a way we can navigate through our network diagram for the cuts and determine the capacity of these cuts. Now, this and all of the other skills we've been building in the previous videos are going to lead us to the next video where we look at finding the maximum flow through a directed graph or a network system. And we're going to do this using these particular cuts. And we're going to draw on a lot of the other concepts we've learned before about the maximum flow as well. But that brings us to the end of this video. Thank you so much for watching, and I'll see you next time.